Okay, so it seems we have some problems with the notes from today's meeting. So I'm going to do this little short video to walk you through the notes that you have. And it should have the same thing that you see on your notes. Today in class, what we worked on was what is called initial value problems. And we started by looking at some background information. And we said that basically, if we take a function y of x and we differentiate it, we will get y prime of x. And since integration and differentiation are opposite processes, then it stands to reason that we could take y prime of x and integrate it and get back to y of x. And that's kind of the premise and the reasoning behind doing these initial value problems. And the best way to see that is through examples. So in our first example here, let's look at the following. Given that y prime of x is equal to x squared plus 3x plus 1, that y of 0 is equal to 4, let's go ahead and find y of x. And so we start off using the fact that we are given the derivative. And anytime you're given the derivative, you can get back to the function simply by integrating. So we know that y of x then will simply be the integral of y prime of x with respect to x. So in this case, it's going to be the integral of x squared plus 3x plus 1 with respect to x. And when we integrate this, we're going to get then 1/3 x cubed plus 3/2 x squared plus x all plus c. Remember your constant of integration. Now what this gives us here is what I'm going to call the general formula. And remember, all we needed to find the general formula was simply the derivative. And having the derivative, then you can get back to your general formula just by integrating it. But we were also given this thing up here, which I'm telling you, which I'm calling an initial condition. And these are what makes this thing an initial value problem. And using the initial condition, we are going to be able to then take that information, put it into our general formula, and get a more specific function. A specific formula. That is, we're going to be able to find C. Let's look at that initial condition. The initial condition here is that y of 0 is equal to 4. And I wrote it directly beneath this particular equation so that you could see what this is saying to us. And this is just a form of function notation. Notice I've got y of x here and then y of 0. That tells me that when x is equal to 0, just looking at the x there, then y is equal to 4. So we're going to take those two things and we're going to put them back into this general formula, and we should be able to then have an equation where we have one variable to solve for, and that is c. So everywhere there's a y, I'm going to put in a 4, and everywhere there's an x, I'm going to put in a 0. So we have y of x, which is equal to 4, and again, I'm looking at the general formula here, is going to be equal to 1/3 times 0 cubed plus 3/2 times 0 squared plus 0 plus c. And then, of course, all of these terms are going to go to 0, and we simply get that 4 is equal to c. Now, that is not your answer here. Your answer is finding a specific formula for y. So we need to take that c value and put it back into our general form, and when we do, we get y is equal to 1/3 x cubed plus 3/2 x squared plus x plus 4. And this, folks, is the answer to your question. And the answer, we always find the specific formula. Okay, so now having said that, let's go ahead and do the same problem, but I want to use a different initial condition. So for this next example, which is our example 2, again, I'm going to give you that y prime is the exact same thing it was. It's x squared plus 3x plus 1. But instead of y of 0 being equal to 4, I'm going to give you the initial condition that y of 1 is equal to 2. And we're going to once again find our y of x. So same exact derivative here, but a different initial condition. Again, anytime we have the derivative, we can get back to the original function. Y of x is simply going to be the integral of our y prime, which is x squared plus 3x plus 1 with respect to x. And of course, we saw this integration already. And we get that y of x is equal to 1/3 x cubed plus 3/2 x squared plus x plus c. And again, this was our general form. We're now going to take our initial condition, which is y of 1 equals 2, and we're going to use this to find c. Again, if you look here at these two, you can see clearly what's happening. It helps kind of understand it a little better, because what this initial condition tells us is when x is equal to 1, see how the x's go in the same place there? Y will be equal to 2. So we're going to go back to this general form, and everywhere there's an x, we're going to put in a 1, and for y, we're going to put in 2. So we get here that 2 will be equal to 1/3 times our x, which is 1 cubed, plus 3/2 times our x, which is 1 squared, plus x, which is 1 all plus c. So we have an equation we can solve for c. 2 is going to be equal to 1/3, since 1 cubed is 1, plus 3/2, since 1 squared is 1, plus 1 plus c. And I can move all of those terms to the other side simply by subtracting them. And so I get 2 minus 1 minus 1/3 minus 3/2 is equal to c. Of course, 2 minus 1 is 1. And then I have a minus 1/3 and a minus 3/2, all equal to c. And I do not want a decimal answer on this. So you're going to need to do it as a fraction. If you know how to do that, please ignore what I'm about to do. I'm going to show you the way I do it. If you already know how to do it, you don't need to follow what I'm doing. But the idea here is that we can only add these fractions if they have a common denominator. The common denominator between, of course, this is a 1/1. So 1, 3, and 2 is going to be 6. That means I need to multiply each one of these by whatever it takes to get a 6 in the denominator. For the first one here, I'm going to multiply this one by 6/6. Notice that the only thing I can do here is to multiply by 1. The reason for that is with equations, I can do anything I want as long as I do it to both sides. But in order to do it to both sides, I have to do the same thing to each and every term, and that's not what I need to do here. Because if I notice for this 1/3, all I need to do is multiply this one by 2 to turn it into a 6. So since I'm not doing that to both sides, I can only multiply by 1, which is 2/2. And then finally, on the last one, I will multiply by 3. Notice that when I do that, they all have the same denominator, giving them a common denominator of 6, and I do what the top is saying, that 6 minus 1 times 2 is 2, minus 3 times 3 is 9, is equal to c. So I get then that c is equal to a negative 5/6, and remember that is not the answer. We're then going to take that, put it back into the general form, and we get that y of x is equal to 1/3 x cubed plus 3/2 x squared plus x plus c.